And so today, in today's session, let's see some basic introduction about binary exploitation. And also, if time permits, let's also see some security vulnerabilities related to voice control systems. So what is a binary? Binary is a machine code for the computer to execute. For example, ELF files on Linux are binaries and exe files on Windows, they are all exes. So, sorry, they are all binaries. So binary exploitation is a broad topic within cybersecurity, which really comes down to finding a vulnerability in the program and exploiting it to gain control of a shell or modifying the program's functions. Let's see why native security or binary security is important. So this mainly deals with security of binaries which are written in C, C++. C++ gives a lot of freedom to the developers, and also they have a lot of responsibility. All the memory allocation functions are developers are free to use them, and they have to manage all the functions themselves. Unlike in Java, where everything is done by the language itself. So obviously, memory corruption bugs will be more in C, C++. So if we look at uh, usage of C++ and popularity of C++, here, as we can see, C++ stands in second, third position. It's much more popular than Python. And some real life examples where they use C++ to implement the code is here. The Mozilla Firefox, the browser is written in C++ internally, and Google Chrome also uses C++. All the Photoshop related functionalities in Adobe also use C++, and gaming functions in all the gaming applications, they use C++ because it is inherently very fast compared to all the other languages. Performance is a huge gain by using this language. Even Windows internally, the operating system, Windows and Apple, Mac OS, they use C++. So let's look at one example of a bug which is related to this and see what the impact could be. So this will be a interactive session. I'll ask questions. You can reply in the chat here. You can answer through the chat. So we all of us have heard about WannaCry virus. Basically, it uses SMB vulnerability. SMB is nothing but server message block server. It is a Microsoft owned code. There was a vulnerability in that code related to overflow. Using that, it was present long back before it was exposed, and NSA had developed an exploit called Eternal Blue. So using, can everyone else? Hello. Um, Someone's video is visible. Is my screen still visible?
And if you see the use cases or sectors in the IoT is.
Okay. Can everyone else please mute?
So I think for interrupting, slides are not visible. If you are sharing.
I am sharing slides. Is it not visible for anyone?
I think it is visible to everybody. Can you please proceed?
Can everyone please mute? Also, someone's video is on. Yeah. Okay, let's continue. Eternal Blue was an exploit developed by NSA which targets this overflow bug, which was an SMB code of Microsoft. Using that, it was targeting remote servers, and it could actually gain remote code execution. Remote code execution means we can run anything on the server. It's like having your like running code on your own computer. If we gain access to the shell of any remote computer, it's as good as my own computer. So NSA was using this for a few years before it was exposed, but later some attackers figured this out, and
Sahana,
then
you're audible. Sometimes it will be getting and sometimes it will not be getting. Can you check your
okay, let me.
Sahana, your voice.
Okay, is it audible now? Hello.
It's audible, ma'am. You can continue. Mr. Jaidar, please repeatedly you are actually unmuting the mic, please.
Sahana, your voice is not audible.
Sorry?
Okay.
Jaidar, please. You can continue, ma'am. I think unnecessarily don't try to unmute the mic, please.
Okay.
There's some background noise, ma'am. I think that's the reason there is an issue from your end.
Like, can you mute everyone else?
Yes, I mute everyone else. I mute everyone else except you. There is a background voice from your end. I think that's the reason.
Oh, I'm not sure.
Is it due to mic or I don't know? There is something. I have muted everybody except you.
Okay. Okay.
Yes, ma'am, you can try it out. You can continue.
Do you still hear any noise?
There is a little background noise actually.
Okay. Okay, let's continue.
Okay.
NSA was using this, and it was, since attackers also got to know this, they were using this to attack some servers. That's why NSA exposed this vulnerability. It reported it to Microsoft, and they later patched it. So even after patching it and releasing the patches, there were many servers which had not upgraded their servers. So as we saw in the previous presentation, one of the most commonly found vulnerability is using old servers, old versions of servers which are vulnerable. So some servers were using those type of like a server which had vulnerability, and some hackers used that, targeted that, and they created this WannaCry virus. I think all of us know about this virus. What happened was they logged all the files and they showed some time. So if you don't transfer some bitcoins by this particular deadline, then we'll delete all the files. That's what they said. And it had a huge impact. So many hospitals had to pay a lot of ransom amount because their patient database was at risk. Even the scanning reports and all the other sensitive information, which is very critical, was at risk. So it is estimated that many hospitals lost around 6 million euros. So yeah, there was a widespread impact. Now let's see some basics of binary hacking. It's going to be very basic, and we'll just see the overview of binary security. Before that, let's try to understand the memory organization of a C program. So all of us know that memory, there are different types of memory. There's stack memory, heap memory. So this is how, as you can see in the picture, this is how the memory layout will be organized. The text section here basically represents the code which we write. The C program which we write will be stored in this section, and all the static variables and global variables will be stored in this initialized data section. All the uninitialized global variables and static variables will be stored in uninitialized section, data section or BSS section. And dynamic memory, when we use malloc, when we dynamically allocate memory runtime, all that memory will be allocated in the heap. And stack memory contains function arguments, local variables in the functions, return addresses. It stores all such information. As we can see, stack grows from high memory address to low memory address, and heap grows from low memory address to high memory address. Is everyone clear on this? This is required, this understanding is required for the next section, where we actually see how to exploit the binary. We will have two examples. Let's look at them. Okay. If you can't see the screen, you can zoom in, or all of you can zoom in. So, okay, let me. Okay. Here, I have an application which is basically written in C++, and the application needs a password to gain admin access, or to gain the privilege, admin panel privilege. We just have the binary. Assume that we just have the binary and we don't have access to code. How can we guess the password, and how can we hack this binary? Let's see what are the possible ways. Okay, so to give you an example, if I give some random password, it says access denied, you are not an admin. So yeah, it just says that. In any binary, what we can do is we can disassemble the binary to get the assembly level instructions and see what the logic is there, and then try to figure out what can we do to hack this. But before doing all that, before disassembling and before looking into the assembly instructions to understand everything, let's use some basic commands to examine the binary. So there's a command called strings. This command prints out all the strings, all the printable characters of strings in any file. So if we use strings app, we can see it is printing out all the strings which is present in the binary. We can see something like success, hello admin, access granted, enter password, access denied, you're not an admin. If we see all this, we can guess that this might be the password, right? So let's try this out. Let's run this application again. Let's try this password. Okay, so this was the password, and it was stored in the binary. let's actually look at the program and see what was there. There is a structure called user. The structure has two fields, password and isadmin. And basically the structure is set to 0 before everything. So it's initialized to 0, and it asks for the password, and it takes the password, and it directly compares the password user input with the password. And if we can see a flag here, int is admin. If the password is correct, string compare will return 0, so this will be set to 1. And if isadmin is set to true, then we are getting access. So what is the most obvious bad practice which you see here? You can type your responses on the chat. Okay, so I'll continue. The password, as we see here, password is stored in the binary itself. So yeah, password is stored, correct. Password is stored directly in the binary. And since this is native code, in the native code, whatever the code we have, with the binary, we can disassemble everything. And when we disassemble, we can actually see this password. So storing any sensitive information directly in the binary is a very, very bad practice. We didn't even have to disassemble the binary to check what the password is. Just examining the strings, we could figure out what the password is. So this might be a backend service running in some server. If we exploit this, we can essentially access we can get access to the shell, and we can control the server and do whatever we want. So, okay, some of you are saying that we can hash the password and store it instead of directly comparing, and we can encode it. Okay, so let's say that the developer, we gave the suggestion, we told this is bad to the developer, and we told the developers to fix it. He fixes this vulnerability, or he pushes the next version of this, which he thinks is secure. Okay, so it says you're not an admin. Now let's try to use the same technique. If we see, there is something else. There's the password looks strange, but let's try it out. Let's see if this works. Okay, it's not working, so access is denied. But can we exploit this even in spite of this? Okay, let's just go to the code and see what the fix is, and see if we can still exploit this. Okay, so this is the fixed version. Instead of storing the password directly, they are taking the user input. They can take the user input and then hash the user input and store and compare it with the hashed value of the admin password. So this is the fix which they have provided. And do you think this can still be exploited? One of you are saying that we can. Okay, theoretically, let's hashing is one-way function. So unlike encryption, we can't decode the hashed value. Let's assume that the hashing algorithm we have used is very safe. In this case, we have used MD5, but MD5 is not safe because we can brute force and we can try to get the initial one. But let's say theoretically, since hashing is one way, let's assume this is one way. Can you think of anything else? Can hashing be done using some salt strings? So what would be the use of using salt here? And since this is binary, like if it is random every time, how will it work? Okay, let's try to see how we can exploit this version of binary. Let's come to fixing it later. Let's just try how to exploit this. Okay, someone is mentioning buffer overflow. Buffer overflow is not needed. There is some noise from someone. Can you please mute? Okay. Okay, as I mentioned before, instead of trying how to fix it, instead of thinking how to fix it, let's try to extract this particular version of binary. Okay. Let's. Can everyone else? Okay.
Hello.
Let's.
Hello, Rajkumar Singh. Hello, Rajkumar Singh. You're unmuting it many number of times.
उसका काम कर उसका 20 दिन एक दिन नहीं जा रहा बुलाया तब जा रहे हैं जाने तो बंद पड़ा है
Hello, Rajkumar Singh. I think.
मालूम नहीं था इस चक्कर में ना वो नहीं किया हमारा भी कारोबार अभी 4 दिक्कत कैसे दिक्कत वही होगी काम धंधे नहीं क्या करे क्या नहीं करे दिक्कत हो गई क्या छोड़ के जाए क्या किराया सब रहे उसको कहाँ खोले सब
Rajkumar Singh. Rajkumar Singh, can you please listen to us? Yes, ma'am, we can continue. I think it's a warning to Rajkumar Singh. Please, if you are not interested, please don't attend the session. You can leave it. Yes, ma'am, you can continue, ma'am. Request all, please mute your camera if you do. What do you want to disturb the entire session?
We have this structure and the password is 40 bytes long, and next to it we have isadmin. And if we go back to the memory allocation of this C program, we see that all the local variables will be stored in stack, and the user input will also be in stack.
Sahana, can you share the screen?
Oh, okay. Okay, let's quickly see it again. If we carefully look at the code, we have a structure, user structure, where password is 40 bytes long, and we have isadmin next to it. And all this will be stored on the buffer since it's a local variable allocated here. And if we go back to the slides and look at the allocation, we get to know that it is stored on stack, and the variables will be allocated one after the other. So let's see what we can do here. So here the password is 40 bytes long. We have allocated only 40 bytes on the stack for the password. What happens when we increase, when we give an input which is greater than 40 bytes? You can answer in the chat session. What do you think will happen when the password which we input is greater than 40 bytes? Okay, there's no buffer overflow here. This is a basic example. There is no array out of bounds. We are not accessing this password using array indexing anywhere in the program. Why do you think it will not accept let's try to give more than 40 bytes and see what happens with the program. Let me first try to print out 40 bytes using Python. Okay, I have 40 bytes. This is some random letter I've used A here. When we enter 40 bytes, I'm not able to copy this. Okay, when we enter 40 bytes, it still says access is denied. Let's try to increase it to more than 40 bytes. Let me append another character. It says success and we have got the access. So what basically is happening here, let's go back to the code and see what is happening. Okay, here when we allocate, when we give an input more than 40 bytes, it overrides the next variable present. It overrides isadmin. So when isadmin becomes non-zero, when isadmin becomes non-zero, as we can see here, it will be set to non-zero value, and this check if u is admin is true will pass and grant access will be invoked. So this is basically buffer overwriting. This is not, this is a basic form of overflow. Variable overflow, it's overwriting the variable. So what are the steps which the developer should have taken while fixing this binary? First and foremost, basic principle in security is whenever any, yes, true, limiting the characters. Whenever there's any user input is involved, we should always think that the user input is untrusted and malicious. That is the basic mindset we should have while developing any code. And so we should be doing input validation no matter, like even if we don't have any sensitive data in the program, or even if we don't have any sensitive operation, it might not involve authentication or authorization. In spite of that, whenever there is user input involved, we should be very careful and we should do input validation. Another bug or vulnerability present in this program is that it is using gets. Gets is actually very unsafe because it doesn't limit the number of characters which is read through the console. Instead of gets, we should always use fgets. It has a parameter called size, which will limit the number of characters read. So this was one of the very basic buffer overflow example. There are a lot of things which we can do using buffer overflow. We can rewrite RIP. RIP is instruction pointer. So if instruction pointer stores the address of the instruction which has to be executed next, if we somehow, and that will also be stored on the stack frame. If we somehow rewrite this, if we rewrite this RIP address, then we can point it to any function which we want and we can execute that function after this. So yeah, as we can see, it's very dangerous. It will lead to remote code execution. Yeah, we saw what are the vulnerabilities which were present in the binary and how to patch the binary. Let's see another real world example. I am sure most of you would have heard of Heartbleed vulnerability. This was a vulnerability in OpenSSL. OpenSSL is an application which is used to implement TLS. TLS is used to encrypt all the communication which happens between machines, like client server communication. All the communications are encrypted using OpenSSL. And okay, what happened? There is a heartbeat message in this protocol where machines send a ping to check if the other machine is still alive. So when a communication is established, if the communication remains uncertainly for a long time, it's bad for performance issues. So there's a protocol. In this protocol, there's a ping message which is sent to the other machine to check if the other machine is alive. In this, we send some character, or we send some payload, and the other machine will also, we will just echo that payload. That is how the normal protocol works. Okay, now what happened is some malicious users, they sent a payload which is 4 characters long, but in the payload length field, they changed the length to some more characters. So if you see here in the example, they sent bird which is 4 character, but length they manipulated it to be 500 letter word, 500 letters. So in the server, it was using, I've pasted a code snippet here, memcopy source, destination source, and this is the length. Payload represents the length here. It was copying the length what was provided by the client. It was basically copying those many bytes, and it was printing it out, or it was sending it to the client in its response. So as you can see, this is really bad because in that system, there might be confidential information like the key for the encrypted session, and all such sensitive information will be there on the server. And when it prints more characters, it will print out all the, I mean, it will send out all the confidential information. So this resulted in the communication channel basically being plain. So attackers could, when we send any username or password from a client to server, since the channel is encrypted, attackers can't really read the password. But in this case, if they get the key, then they can decrypt the message and they can actually get access to password, username of bank sites, and all other confidential information. This was a very bad, one of the very and I've pasted the fix for this. The fix was just to check the length, validating the length which they have given, to check if it is more than, if it is more than the payload length itself, then they're returning 0. This was a simple fix. As we saw in the earlier program, it is somewhat similar to that, but it caused so much damage earlier. So as I said, this was a very basic overview of binary exploitation. I didn't even cover rewriting EIP or anything like that. This was just an introduction. You can refer these materials to get started, and you can, so there's one YouTube channel called Live Overflow. It is very good for starters to get an understanding of buffer overflow, stack buffer overflow, heap buffer overflow. And I also encourage all of you to participate in CTFs. That is how we learn all this. And some materials to get started with CTF is present on the CTF 101. And Pornable.xyz is also a very good site to practice. And there is another blog which you can refer. And here today we didn't really show disassembling or using debugger to figure out how stack looks or heap looks, but it is required for all the other advanced problems. You can use Pond debug for that. And basically, if you participate in more CTFs, you'll gain a very good knowledge in this area. So, do we still have time to talk about vulnerabilities related to voice control system? Organizer.
You can continue, I think.
Okay. So I'll just briefly give an overview. I'll not cover everything in detail. So this is a different topic. Whatever I showed earlier, it's related to binary security. Now let's briefly look at security of voice control systems. Okay, let's take some questions before continuing. I think there are a lot of questions. Okay, so these materials, I'll upload the slides. You can get these links using the slides. Is there any other question? Okay, let's continue. Okay. We know that voice assistants are becoming very prominent nowadays. We see Google Assistant in all the smartphones, Siri in all iPhones, and there are so many smart devices like Alexa, Google Home, everywhere. And they have, we can achieve basically anything we can achieve using mobile assistants now. So, okay, let's here in this presentation, let's look at some of the attacks on voice control systems, some defense mechanisms, and some future research work related to voice control system security. Okay, so Juniper has estimated that there are 3.25 billion voice assistants in use. This was in 2019. And it's growing exponentially because speech is the natural way of communication for human beings. It is the new form of touch. Like instead of using keyboard or mouse, we can just give a command and then it will be executed. So although the capability of voice assistants are growing tremendously, is the security matching up? There is not much work done on the security of voice control systems as of now. And as we can see, this is very dangerous. For example, if security and privacy of us can be exposed, like if Alexa is compromised or any smart device is compromised, it might lead to many privacy concerns and security concerns. It can take control of household equipments. It can do unintended shopping and banking transactions. Let's quickly look at various attacks which have been attempted in the past. Voice employer. This was an Android app which was developed by some researchers. So as we know, in Android applications, it has something called Android permissions. App will get only required permissions. It doesn't get any more permissions than required. Like app which doesn't need to have permissions to call or message will not have permission. Let's see how we can bypass it using voice assistants. So they wrote an application which will invoke Google Assistant. And when it invokes Google Assistant, they also had an audio file which will give command to call someone. So a voice assistant is invoked, and the program also reads this audio file to the voice assistant, and voice assistant has all the permissions, so it can trigger calls or messages. So this is one example. And Alexa had used Alexa exposes a variable called should end session to external skill developers. If this is set to false, then the session doesn't end even after skill is invoked and the processing is done. So this can essentially hear all the conversations. It's a big privacy risk. Skill squatting attack. Okay, so we know what skills are. We also know Alexa can go wrong, or voice assistants generally go wrong in it doesn't interpret many things properly. Okay, it doesn't interpret many things properly. For example, if we say facts, it's hard to differentiate between FAX facts and FACTS facts. So it's inherent nature of voice. So it will lead to many errors. What if we use that errors intentionally and develop a skill which sounds similar to some proper skill? If there is an app which does banking transaction, what if I develop another which is AMX? So whenever Alexa interprets it differently, this will be invoked, and this can send a phishing page to the mobile device, and we might compromise our banking credentials. So this is one type of attack. Smear skill squatting mainly focuses on demographies because pronunciation is different in different demographies. So probability of users landing into malicious skills will be more in this case. Also, we know that Google Home has voice authentication. It doesn't work if others give any commands. But this is also not so useful because we have voice morphing attacks where if we collect some samples of targets, person A, if we collect some audio files of him, we can use that to train machine learning models to get his voice and commands in his voice. Hidden command and inaudible commands are also proved. So we can basically, if there's a very famous video, music video, we can embed some command inside it which can't be interpreted by human ears, but Alexa can interpret and run that command. Inaudible command also works because it exploits some hardware non-linearity loophole, and if the target is within 25 feet, it can use some ultrasound waves which humans can't hear but Alexa interprets. I quickly covered various attacks. Minimizing the risk, what we can do is instead of using the normal trigger word Alexa for Alexa, we can customize it, we can change it to our own name. We can give a customized name so trigger word can't be predicted. And there is a lot of research going on related to the communication protocol. So when we communicate through website in TLS layer and all that, we have a proper communication protocol, but when it comes to voice, we don't have a protocol to authenticate that the user is actually who he says he is. So there's some research going on related to that. And finally, users tend to intrinsically trust IoT devices more than online websites because websites, we all know that there can be malwares. There are softwares, antivirus softwares, which shows red color saying there might be malware here. But and if the website is safe, it will show green tick saying this is safe. But when it comes to voice devices, we don't have anything like that. We tend to trust the device completely. So this is in our mindset, and we have to do some work, research work to like enable some safety measures for this. This is an open problem. A lot of research is going on. You can refer, you can learn more about all the attacks using these references. Yeah, do you have any questions? Okay, I think it's way beyond the time. We can end the session now. Thank you all.
Thank you so much, Sahana. Thank you so much for your time.
Okay.
Thanks a lot.
Yeah, now we will have a break till 12 o'clock. Then we will start the session at 12 o'clock. Okay?
I will stop the recording, ma'am. I think that will be fine, right?
Yes, sir. Yes, sir. You can stop, sir.
Okay.